This is the third video for the Geometry Semester 1 midterm. We're looking at number 23. We're going to use constructions to help bisect this object. This is a segment. Now we could use a compass, and there's a technique to making curves and showing how our compass can show this bisected. The way that we did this in class was to actually just fold the paper. We're going to try to put our one end point on top of the other end point, and that will also bisect and show us exactly where that midpoint is. So we'll take our paper, a little tricky to do under the video, but we're going to take both our end points, line them up with each other, and that will show us right where the midpoint is located. That will bisect the segment. For an angle, we're going to take our angle and we're going to try to do the same thing. This is a bit trickier to do with paper, but keeping it tight, we're going to put both of these rays right on top of each other. I'm going to put the two little arrows on top of each other. Keep the paper tight. I missed it. Let's try that again. Keep the paper tight. You need to be sure that they line up coming down to the vertex also. Okay. That might be the best one I got. All right. So we see that here we drew an angle bisector. You can do it with a compass. It's kind of neat, but we talked about folding it. All right. For this next group, we're looking at parallel lines. Now there's a few things we're supposed to think about when we see parallel lines. You got to find either corresponding angles, alternate interior angles, alternate exterior angles, or consecutive interior angles. Those are the different types of angles that we typically are looking for if two lines are parallel. Corresponding angles, if the lines are parallel, then corresponding angles are going to be equal. If two lines are parallel, then alternate interior angles are congruent. When we look here, we see this Z shape being formed. So we're going to call them alternate interior angles. If the lines are parallel, then alternate interior angles are congruent. So we can say that 80 equals x plus 15, subtract the 15, and we get x, which would have to be 65. It's not 65 degrees, it's just a 65 value for x. The 65 and the 15 add up to equal 80, which is a degree. On this side, we see consecutive interior angles. If two lines are parallel, which we know these lines are parallel because they have arrows in them. If the two lines are parallel, then consecutive interior angles are supplementary. So we know that 2x plus 68 has to equal 180 because those two angles have to be supplementary. We'll subtract the 68 across and get 112 divided by 2 gives us 56 degrees. Well, sorry, x is not a degree. X is a value. When you times it by 2, we're going to get wait a minute, what's not making sense here? Okay, at first I was thinking they were equal to each other. No, they add up to 180. So if this is 68 and this is 112, the value of x itself is 56. Alright, again, here we have two parallel lines. We know that because the arrows are inside the line showing us that the lines are parallel. These are called alternate exterior angles. They're on opposite sides of the transversal, but they're on the outside of our two parallel lines. If alternate exterior angles we're starting out, we don't know about the alternate exterior angles. If two lines are parallel, that's what we know for sure. We have our two lines parallel. If the two lines are parallel, then alternate exterior angles are congruent. So I know that 2x minus 4 has to equal 92. We're going to add the 4 over to get 96 and divide by 2 to get 48. Okay, looking at letter D. What type of angles are these? You should be able to look at this by this point and know what type of angles those are. If they were in these two spots, they'd be called corresponding angles. If they were in these two spots, they'd be considered alternate interior. Alternate exterior is what we just worked with. And these are consecutive interior angles. If two lines are parallel, then consecutive interior angles are supplementary. So I know that 75 plus the 5x minus 10 has to add up to equal 180. Here we get 5x plus 65 equals 180. Subtract the 65 to the other side, and we get 115. And when we divide by 5, we get 23. Answer the question, which is find the value of x. So we found the x each time. I also went through and wrote in the theorem that allowed us to set up that equation. It's not a guess. Sometimes they're equal, and sometimes they add up to 180. You've got to know what you're looking at to be able to determine which is which. For these questions with number 25, notice we don't have any arrows on our lines. That is showing that these lines are not necessarily parallel, but we can still have corresponding angles. We can still have alternate interior, alternate exterior, or even consecutive interior. They just won't be supplementary or congruent to each other. 2 and 5, they form this C-type shape. It might look like a U from that point of view. They are consecutive interior. Two and 8 are forming this zigzag. So they're alternate interior. 3 and 9 again are making this zigzag shape. If you trace out angle 3 and you trace out angle 9, you're making this Z shape. And we've determined before that alternate interior angles are the only ones that make that shape. Nine and 15, if you trace out 9 and notice trace out 15, they are not next to each other at all. They're not making a Z shape when you do that. They're completely separate. We're going to call these alternate exterior angles. 4 and 8, notice that 4 and 8 are compared to the vertex are both down and to the left, down and to the left. That makes them in corresponding positions. So they're corresponding angles. 1 and 11, what type of angles do you see them to be? Again, they're not, when you trace out their angles, they don't overlap at all. They're alternate exterior. 3 and 11. 3 and 11, when you trace out the 3, you trace out the 11, you could say that they make an F shape. Or you could look at the vertex and say they're both to the lower right. The lower right, they're in corresponding positions. Eight and 13. What type of angles would 8 and 13 be? When you trace out the 8 and you trace out the 13, you get this like C shape. This is kind of a backwards looking C, but it helps me remember that we have consecutive interior angles. You need to be able to recognize those 4 types of angles. They're very helpful, and you'll use them when the lines are parallel. Here on our next page, we're looking at a crazy looking figure. We see arrows, so we know that this line is parallel with that line because they both have the arrows on it. So name a pair of parallel lines. So we have PM, we can put an arrow above that, is parallel to QS, for line QS. Name a pair of perpendicular. Well, we can recognize perpendicular by the square. So we have this way and that way that are forming off this square. So we have VN is perpendicular to TR. There's a question, is line OL parallel to line TR? TR is right here. OL is right there. So definitely not parallel. They're not going in the same direction. No. They intersect. No, they intersect. Is OL, that's this line, and TR, are they perpendicular? Well, we look at them and they're definitely not parallel. They intersect, so maybe they're perpendicular. Do they form a right angle? Well, sometimes it might even look like a right angle, but this one doesn't look it, and it doesn't even have a box in the corner, so no. How do we know they're not perpendicular? There is no indication. There's no indication they are perpendicular. Alright, we have a couple of proofs that we're going to look at. We've looked at this type before. We have angle 2 is congruent to angle 3. We know that from our given information. Now I have to prove that angle 1 is congruent to angle 4. Whenever you do a proof, you have to determine how this can happen. You have to decide on your own before you try to do the proof, can this be done? Do you recognize how to get there? How will angle 1 be congruent to angle 4? I'm noticing that if these two are congruent to each other, 2 and 3, I know that 1 and 2 are congruent to each other because they're vertical. 3 and 4 are congruent to each other. So that's going to make 1 and 4 congruent to each other. So I think we can do this. We're going to start out with our given. 3 and 4, if two angles are vertical, then they are congruent. 2 and 4. So now, how do I know that 2 is the same as 4? That's the transitive property of congruence, like we talked about earlier in this lesson, on this review even. We know that 1 and 2 are congruent. Because they're vertical angles. If two angles are vertical, then they are congruent. So now, since 1 is congruent to 2, and since 2 is congruent to 4, and 2 is congruent to 1, 1 and 4 are congruent to each other. That's the transitive property. Transitive, POC. This is an algebra proof. We start out our algebra proofs. You don't have to think and set out plans as much for an algebra proof. You just kind of do with what is in front of you. So we'll probably distribute the 5 through. So we call that the distributive property. Now we don't call that of equality because you don't do it to both sides. Distributing is just in one spot. Subtract, that's actually a 2, sorry. Subtract the 2 across, and you would get 3x. And we call that subtraction. Property of equality. Add the 5 across. So that's addition. Property of equality. And then we'd finish it off. Divide by 3, divide by 3 to get 5. That's a division. Property of equality.